Airplanes do not fail the way most people imagine. They do not fall from the sky because one thing breaks. They fail when multiple systems behave correctly, but in the wrong order at the wrong time. Modern aircraft are built around redundancy. Every critical function, flight control, navigation, power, hydraulics, exists in layers. One failure is expected. Two failures are tolerated. Accidents happen when failures interact. The first category is sensor failure. Aircraft do not feel speed, altitude, or angle. They infer them from sensors. If a sensor delivers incorrect data, the system does not know it is wrong. It treats the input as reality. When speed sensors disagree, automation must decide which one to trust. If logic selects the wrong reference, control laws change. Protections may disengage. The airplane is still flying, but under a different rule set. The second category is automation mode confusion. Modern aircraft operate in modes: climb mode, speed hold, altitude capture, manual override. Each mode changes how inputs are interpreted. A pilot may move the controls expecting one behavior. The aircraft responds according to another. Nothing is broken, but intent and execution no longer match. This mismatch has caused multiple loss of control events. The third category is energy mismanagement. Aircraft stay airborne by managing energy, speed, and altitude. Automation often manages this silently. When automation disengages unexpectedly, energy management becomes manual instantly. If thrust is low, altitude is high, and speed decays, recovery margins shrink rapidly. At altitude, stall recovery takes longer. Control inputs that work near the ground may fail higher up. The airplane does not stop flying. It runs out of usable options. The fourth category is system interaction under stress. Hydraulic loss may affect control surfaces. Electrical failures may disable sensors. A software protection may disengage because its assumptions are violated. Each system responds correctly in isolation. Together, they create a state no designer explicitly planned for. The final category is human system timing failure. Automation reduces workload until it doesn't. When failure occurs, it often occurs suddenly. The human re-enters the loop with incomplete context, high workload, and limited time. Training covers scenarios. Reality combines them. Airplanes rarely fail because of one cause. They fail because systems align into a configuration where recovery is no longer available. This is why aviation safety focuses on system behavior, not blame. The aircraft did not malfunction. The system reached a state it could not exit. Understanding failure means understanding interactions, not parts. That is how airplanes fail.